and welcome to day 4. We are going to create a very nice project today about smart traffic lights. So we'll start, of course, with microbit, but instead of one, we're going to have 2 microbit. So I dragged 2 over here. I'll put one as yellow and the other as green, but you can choose your own colors. And then we are going to get 2 breadboards, the small one. So I'm going to drag 2 as well. And then we are also getting a force sensor. There we are. And then we are going to get a couple of LEDs and resistors. So I'll get 5 LEDs. 1, 2, 3, 4, and 5, and then 6 resistors. Okay, and then we are going to start connecting. Let us start with the first microcontroller, the green one. First of all, you need to rotate the breadboard, so you can either click on the rotate button for both of them, or you can just click on R. Press on R on the keyboard. Okay. Moving on, we are going to put the LED lights. So I'll get the first LED light, which is, and normally in traffic signals we have red, yellow, and green, and this is exactly what we're going to do. So let's get one. And of course, for every LED light, there's the anode and the cathode. So make sure you're connecting it correctly. I'm going to rotate it. And then I'm going to put it here. And then I'm going to get another one. I'll put it as yellow. Rotate it. And then put it here. And then a third one, and of course this would be green, and rotate it. Okay, next we are going to put the resistors. So I'll get the first resistor, get 3 of them actually, just to be close to the circuit. Here we are. So the first resistor, I'm going to change its value to 50 ohm. 50 ohm. Okay, and then I'm going to rotate it, and I'm going to put it here at the anode of the resistor. So just to make sure, the terminal 1 of my resistor is within the same line of the anode. Okay, let's repeat the same thing again. 50 ohm. So we have to change the unit as well. Then we have to rotate, and then we put it here. We do the same thing. Make sure that they have a free end over here. Make sure that they're not connected to the cathode of the LED light. Okay, and I'm going to rotate it. Here we are. So now we have the resistors. We already plugged them in the breadboard. So let's move this rest of the components so we can put them in the second breadboard. Just gonna move them close. Okay, so let's start with the force sensor over here. So the force sensor will have a 1 and 2 terminal. We are going to rotate it as well. 1 minute, let us just fix it. Okay, so we have 1 and 2, and I'm going to connect them here. Okay, moving on, I'm going to add some LEDs. The first one, I'm gonna put it as green. Also rotate. And then add it over here. Then the second one, which is red, also rotate. And then add it here. Okay, and then we are going to add our resistors. So the first resistor, I'm gonna put it as also 50 ohm. And rotate. And connect it here. It has to be the same line as the cathode over here. Moving on, we have 50 ohm. Rotate. Same thing. Okay, and then the last resistor, it will be at the force sensor. Okay, so I'm gonna put it here, and its value would be 10 kilo ohm. Okay, and here you need to notice how the colors change when you change the value of the resistance, because the colors indicate the value of the resistor. Okay, now let's start wiring. First, it is very conventional, or it's very easy to start with the power and the ground. So let's make it easy for us. We'll just connect the power, and then we're gonna the ground, and then we're gonna connect the power. There we are. So they're both connected. Now we're gonna connect each pin to something specific, and we need to remember what we connected each pin to. So the first pin over here is the 0. So let's put it with green, and we are going to connect it to the green LED. So it's over here. I'm going to connect it to the green LED. So as you can see, it's connected to the anode within the same line of nodes. Okay, moving on, we'll connect one to the red LED. Here we are. And obviously we are going to connect number 2 to basically the force sensor. So I'm gonna change the color of the wire to yellow, just to remember or differentiate between what you're connecting. So I'm gonna connect it to the same node as the terminal 1 and the resistor. Okay, are we done? No, not yet, because we need to connect the ground and the power to each and every component here. So let's start with ground, black. So we need, no, this is yellow, 1 minute. Okay, so we need to ground each and every component. Let's do that. We'll start with the first component here, the LED light, which is connected to a resistor, and I made sure that it is connected to the resistor, that the line, or it's the same line of nodes. Again, over here, and obviously we are going to connect also the power, the force sensor as well. We are going to connect it to the ground. Okay, Moving on, we are now going to connect the power, which is the red. This is black. Now we are going to connect the red wire because it normally represents power, but make sure you are connecting it to the positive line. Okay, so you grab it, try to click somewhere in between, and then connect it to the second terminal over here, terminal 2, and make sure that you did not touch any other pin. Okay, so it's directly connected from the node of terminal 2 to the positive line. Okay, so this is the connection of this microbit. Let's go and do the same thing for the other microbit. So again, we are going to connect the power and the ground. So I'm gonna get the 3 volt, connect it to the positive, then I'll connect the ground, connect it to negative. Next, I'm going to connect the signal, but before connecting the signal, I can just ground the resistors already. And I think you are familiar already how do we ground the resistors or the LED lights. So you make sure that you are within the same node. Okay, so we grounded all the LEDs. Now let us connect the signal. I'll choose green to match the last LED with the microbit. So for 0, I'm going to connect it with the red LED light over here. So make sure it is connected to the same line with the terminal 2 of the resistor. Let's move on. There we are. Just make sure it's neat, so you know what you're doing. And then again, so I'm just going to make some space to make sure we are away from, we know each wire where it's going exactly. So now I connected all the wires. Make sure your connection is right, because you might find problems later on in the program if you did not connect it correctly. And remember which LED is connected to what pin. Hello everyone, and welcome to the programming part of the 4th day. We are going to start programming this microbit, the one that is connected to the force sensor. We'll go to code as usual, and then we are going to start with onStart, and then just like last time, we are going to set the group. So for this time, let's try to, you can put whatever number you want as long as you set the same for both microbits. Now let's move on. We'll get a forever loop, and then from the forever loop we are going to start a variable. And what is this variable? We are going to create a variable that is called counter. What is the use of this variable? Basically, we are trying to count the so you know when you see signals in the street and then they have like a countdown to when you can move, or a countdown to when the signal turns from like red to green or from green to red. This is the same thing. This is why we created a variable that is called counter. Okay, so we will set counter to 8. Okay, so we want our traffic light to start counting from 8. And then we are going to create another variable, which is force. Okay, and this variable, I'm going to set it as well. Set force to, and then what we need to do is we need to take the reading from the force sensor. How do we do that? We'll go to input and we will say read analog pin. And remember, which pin did we put the force sensor to? Let's check again. There we are, it's the red wire, so it is connected to P2. Okay, so make sure you understand what you're doing. Moving on, we are going to start with a condition. So this is why we need an if statement. But this time we are getting a if-else statement. So we're going to put inside the forever loop an if-else statement. Okay, let's start with the condition itself. What condition do we need? So we'll go to math and we are going to choose this operator. And we are going to choose, instead of equal, we're going to choose larger than. Okay, what is my condition? If the force is larger than a specific number, then we will have a set of outputs, you can say. So how do I do that? We'll go to variables, and then I'm going to choose force, and then I'm going to choose a value of 700. So if my force that I took from the force sensor is larger than 700, I will do the following. I will show the number. So which number am I showing? Let's say when you are walking and want to cross a street, what you will do is you're gonna basically click on this machine where it will, after a while, it will close the car's traffic light and it will let you pass. How will you know when you are passing? It's exactly like when you are clicking on this force sensor, and then after you click on the force sensor, you will have the counter going down till you can pass this street. Okay, so we're going to show a number, and which number is this? What is telling us the time or the how many seconds are left? The counter. So I'm gonna put down the counter. Okay, and then what am I going to do? Now, if I put the count as it is, it will just show me 8 because it doesn't go down. How do I make it go down? We are going to put it inside a repeat function. So I'll take the show number out for now, and then I will get a repeat function. There we are. And I'm going to choose the conditional repeat function. Why? Because I need a condition. Here's why. So if it's 8, for example, and then I keep repeating, it will keep on the countdown. It's gonna go like 8, 7, 6, 5, 4, 3, 2, 1, and then start over because we are repeating. So we need to put a condition for this repetition to end. How will we do that? We will basically say repeat while the counter is larger or equal to 0. Let's try to do that. We're going to go to math, choose an operator, and then choose your counter, and then choose larger than or equal to 0. So that means that the minute it hits 0, that's it, we don't repeat anymore. We get out of this repeat loop. So we show the number, But then what do? The number will stay 8 if we don't reduce it. So, and we have to reduce it by 1 because it's 8 minus 1 is 7 and 7 minus 1 is 6. So all we need to do is we need to set the counter to the value itself minus 1. Let's see how we can do that. Again, set inside the repeat loop because we are repeating this process. And then we are going to add some math. You can choose this, for instance. There we go. It's inside the second circle. And we are put minus. And then we're going to put the counter. Okay, no, not correct. Let us put it inside. And then let us get the counter. We need to put it instead of the 1. There we are. So I put it instead of the 1 and then minus 1. So every time the counter will keep reducing by 1 till it hits this condition and it gets 0, so it goes out of the loop. Okay. Now it's better as well to leave some sort of a delay in order to see what's going on. So I'm gonna inside the repeat loop, I'm gonna wait for, let's say, 0.5 seconds. That's good enough. Okay, what's after that? You are going to send a radio number just like last time. Okay? Okay, so I'm going to send a radio number because we are trying to communicate with the other microbit. Where do I put it? Before else. So it's after the repeat. However, it is still within the if part, not the else part. Okay? So radio send number 1, and then we are going to do the following. Digital write pin, and we are going to connect P1 to low, and then digital write pin P0 to high. Okay, let us see what does this mean. What is P0 connected to? Green. And what is 1 connected to? Red. So when I say P1 is low and P0 is high, that means that the green will lit up because it's high. So now, once the countdown is done, you can walk. And when you can walk, that's when it's a green light for the pedestrians, of course. Now, as well, just like we do every time, we need to add some delay just to see the results, so nothing happens too quick, okay? And we wait for 8 seconds. Okay, moving on, now we will start filling in the else part. What will we do? So if none of this is happening, none of the condition of the if is happening, what will we do? We will send number 2. Okay, we will send send number 2. Okay, and then we are going to light something up, and I think you can tell by now what we're going to light up. So we're going to put 2 digital write pin, and P1 should be high and P0 should be low. What does this mean? So if there is we are not sensing any force, no one clicked on that machine, there are no pedestrians, by default the green light for the cars will keep on moving and you will have a red light for the pedestrians. Okay, and let's make it a bit more interesting and do the following. We will show an icon that is X, do not move. I think it makes a lot more sense to do that. Okay, now of course, just like every time, you will have some sort of a delay just to show what's going on. And then eventually we are going to clear screen, and this comes after the if condition. We do not want anything to happen in the if condition. Now you're done with programming the microbit for the pedestrians. Now let's move on to the microbit for the cars. Make sure you click on it, the green one. Okay. Of course, you can tell already what the first step would be. I'll give you a hint. What was the first step here? There you are, on start. And then you need to set the radio group, which is 2. Okay. Now, on radio received number. Why are we doing this? Because this is the one receiving the readings. Okay, so we'll go to on radio received number. There we are. On radio received, not a string, sorry, on radio received number. Okay, on radio received number we'll have a, let me put this up, and then we are going to set another variable. Okay, let us see what variables do we have here. We already have value, but do we have any other variable? No, let's create another one then. It's going to be called counter 2. So now we know that the first counter is for the pedestrians, the second counter is for the car. So I'm going to set counter 2 to 8. Okay, and then I am going to add an if condition, and this time we are also going to use an if else condition. So go down and choose if else condition. Okay, what do we need to do in this case? Let us set the condition. It's going to be a math condition. Here we are. So if the value that we have, let's get value, is equal to 1. And what did we set here when we programmed this one? We set to send number 1, okay, when you basically sense something, okay? So if we have 1, that means we are sensing some force, we are going to light something up. What are we going to light? Let's see. I'm going to put 2 digital pin. So I'm going to set the pin 0 low and pin 1, 2 high. Okay, let us check what we did here. 0 is connected to the red one, 1 is connected to the yellow one. So the minute we sense something, we sense a pedestrian, we are going to light up the yellow LED. So that means, okay, cars, you need to slow down because we will have a red light coming soon for the pedestrians to move. Okay, am I done? No, not yet. Let us have some repeat while. But inside, this is all before the else. So repeat while and exactly the same thing again. We will have the math, we'll have this math operation, and instead of counter, we'll have counter 2, as long as the counter is larger than 0. Okay. What will happen? Let us light some LEDs. So I'm gonna get 3 digital right pin. There we go. 3 digital right pins. 0 will be high. P1 will be low. and then P2 will be low. What does this mean? I'm lighting the red light. Okay, so as long as the counter is larger than 0, lighting the red light. Okay, and then what else is there? We need to show the number, of course. And what is the number? It is basically our counter, because this is the counter for the cars to stop, and then they will start moving. So I will set the counter to, of course, another math program or other math instruction, and I'm going to make it, instead of plus, a minus, and instead of 1, I'm gonna get my counter to, because it has to decrease, right? And it's gonna keep decreasing till we get out of the cycle. And of course, as usual, we need our delay. So we wait for maybe around 0.8 seconds. Okay, so what have we done so far? We made sure that it will stay. The minute we click on the force sensor, we will transmit some kind of signal for the cards to start getting ready to stop moving. So it's gonna be yellow, and then it will turn to red, and then the counter will start, and it will keep decreasing till we have the cars can go back. Okay, let's then continue. Digital right, and we get out of the cycle. Now we broke the cycle, we're out of it. And we have 3 LED lights here, so P0 should be low, that's it. If the condition is not satisfied, that means the car can move as they wish. And then P1 will be high, and then P2 will be low. So we're getting back to the yellow color, as you can see. Okay, so we're gonna wait a bit also before the else for 1 second, and then we will get the digital pin, which is P2 too low. Okay, and then we wait again for 1 second. Okay, so what if there is no reading and we're ready, cars are okay to move? We can first of all show an icon. Like this, that you can move. And then we will get 3 pins as usual, or 3 LED lights. Okay, first one should be low, which is P0. P1 should be also low, because, well, now the cars can move. So which one should be high? The green one, P2. Okay, after that, let's have a small delay outside, okay, for 10 milliseconds. So it's just a very small delay, and then you clear the screen. Okay, and that would be the end of this program. Let's see if it works. I will start the simulation. Okay, so now no pedestrians, cars are moving, it's green, and here if you come, you cannot cross, and our LED light is red, sorry. Let us just move this a bit because we don't need it. What about if I click on the force sensor and I give some reading? See, I start the countdown. 6, 5, 4, 3, 2, 1, 0, and then it goes green for the pedestrians and red for the cars, and it starts the countdown. Okay? And then it goes yellow. But then what happens? The signal is still there. So it keeps repeating because we still have some sort of a reading. What if I make it 0? So no pedestrians no more. Okay, becomes red, no crossing, and then it goes yellow and green for the cars, and they can start moving. So that was the end of the program for day 4. I hope that it was easy for you to understand. And here's what you need to do for the special mission. You need to add a PIR sensor to detect movement instead of a force sensor. So that would be even a smarter idea. So instead of me trying to click on something in order for me to cross the street, why can't I have a sensor that will just sense my existence because I am moving, for example? Let's see what you will do. And of course, don't forget, in order for you to share your mission, you need to send to invite people and copy your link and submit it for both the main task and the special mission.